Morning, all of you. Yesterday we have discussed about types of mechanical waves. Those are, first one is longitudinal wave and the second one is transverse wave. What is longitudinal wave and what is transverse wave? Already we have discussed about it in before class. Now we are going to compare the longitudinal waves and transverse waves. First of all, what is meant by the longitudinal wave means when the direction of the particles, which is having vibrating particles from its mean position, is parallel to the direction of propagation of a wave is called as a longitudinal wave. Means when particles of the medium vibrate along the direction of the propagation of the wave is called as a longitudinal wave, and in this longitudinal wave compressions and refractions will be formed in alternatively. Means when if the compression will form, then after the compression the refraction will be formed. Already we have discussed about the, for example, spring. Whenever spring is vibrated, then at some place the total normal distance will be less than the actual distance. After that compression, the normal distance will be more than the normal. Compression means when the normal distance is less than the other one, that is called as refraction. So after compression, refraction will be formed in the longitudinal waves. So alternatively, the refractions and compressions will be formed in longitudinal waves. And these waves can be formed in solids, liquids, and gas. All of type of matters, the waves can be possible. Longitudinal waves can be possible. And whenever the longitudinal waves are propagating in a medium, when the longitudinal waves are propagating in a medium, the pressure of the medium will be changes. Means whenever the longitudinal waves are means, then the longitudinal waves are moving through the some of the medium. For example, if the spring when the longitudinal wave, when the spring is vibrating, then the pressure between the particles of the vibrate particles will be changes. So the waves can be formed in solids, liquids and gases, as well as the pressure changes in the medium, because of they will form compressions and refractions. That's why the pressure will be changes in the medium when the longitudinal waves are propagating. Next one, they indirectly represents the sine wave. We know that what is sine wave means whenever the waves are moving in like this can be called as a sine wave. When it is having that, the point will be started at the 0 point and it will go through the maximum and minimum distances. This wave can be classified as a sine wave. So indirectly, because of here the waves can be moved like this, compressions and refractions, like this, compressions and refraction. So that's why we can say that in the longitudinal waves, they indirectly represents the sine wave, and so that's why they cannot be polarized. Polarized means whenever the light is moving or sound is moving, when the waves are moving in the several distances, they can be polarized. Means they can be moving to the specified direction, that is called as polarizing. So these longitudinal waves cannot be polarized because of they are moving in a say parallel to the direction of the wave. So that's why they cannot be polarized. This is about the longitudinal wave. Means when the vibrating particles are moving in the parallel, moving in the direction of the wave, and in this refractions and compressions will be formed. And next one, the waves can be formed in solids, liquids and gases also. And one more thing is the pressure changes when the longitudinal waves are propagating in a medium. The pressure changes, and as well as indirectly represents the sine wave. Indirectly represents the sine wave, and this can be polarized. This is about the longitudinal wave. If we come for the transverse wave, transverse waves means if in this longitudinal wave the vibrating particles are parallel, means in in the direction of the wave. But in transverse waves, the vibrating particles are right angled. The vibrating particles are right angled to the direction of the wave is called a transverse wave. In this transverse wave, thrusts and troughs will be formed. Thrusts and troughs will be alternatively formed. Alternatively formed. Thrusts and troughs are alternatively formed in a transverse wave. These waves can be formed in a mostly this type of transverse wave formed in a solids and a surface of the liquids. Why? Because in the surface of the liquid only the waves will be formed. We can see the oceans or lakes. Whenever the water layers are moving upon surface of the parts only, but inside the rest of water will be stationary. So that's why we can say that whenever the liquids are flowing, then the surface of the liquid only they will move in the transverse wave. Other remaining liquid surfaces inside the liquid they will stay at a same normal stress. So that's why we can say that these waves can be formed in solids and surface of liquids. Only surface of liquids. And whenever the transverse waves are propagating in a medium, there is no pressure changes. There is no pressure changes. Only whenever the longitudinal waves are propagating, only pressure changes in a medium. But transverse waves when propagating, no pressure changes. And these waves directly represents the sine wave. We have discussed about sine wave. Sine wave is like this. So here is that whenever the body will start, the wave will start, it is the maximum displacement of vibrating particles from its mean position in positive direction. It is called as a thruster. And whenever the maximum displacement of vibrating particles in negative direction is called a trough. So that's why we can say that this is also directly can be represented the sine wave only. And one more thing is, whenever the sine waves are moving like this, then this can be polarized. This can be polarized. Means the direction is different because of it is moving perpendicular to the right angle. It is perpendicular to the direction of the wave. So that's why we can say that these these waves can be, transverse waves can be polarized in this direction. So now we discussed about comparison between the longitudinal and transverse waves. Now we are going to discuss about whenever the progressive wave, the displacement relation of a progressive wave. What is progressive wave? Means when a wave in which travels in a given direction with a constant amplitude. Constant amplitude at a given direction, given position and with respect to instant of time. At any given instant of time and position, the amplitude is constant. So that wave is called as a progressive wave. Means a wave which travels with a given direction with a constant amplitude is called a progressive wave. If in case of every progressive, in this case, every progressive wave is a periodic wave. So, what is meant by the periodic wave means at any instant of time or at any instant of distance or position, the particles vibrates, amplitude is constant, is called as they repeat itself. The same constant distances is called a periodic. So, here the progressive wave function represents the periodic wave. This can be the periodic traveling wave relation can be classified like this: y of x comma t is equal to a sin of kx minus omega t plus pi. This is the relation for the displacement. Here y is denoted as a displacement and with respect to position and time. X means by the position, t means by the time, and a small a is denoted as a amplitude. Here the sine wave can be classified, and k means angular wave number. Angular wave number means the number of waves can be classified in given distance is called the angular wave number, and x is the position, and omega is denoted as a angular frequency, and as well as pi means phase. Pi means phase. So here that y of x comma t is equal to a sin of kx minus omega t plus pi. So the wave displacement of a relation of a progressive wave is represented y of x comma t is equal to a sin of kx minus omega t plus pi. Then at any fixed instant of time t is equal to t naught, then the displacement relation will become like y of x comma t naught is equal to a sin of kx plus constant. Constant means here the time t is equal to t naught is a constant, some fixed time instant of time. So that's why the term omega t plus pi phase angle will also become the constant. And here is that the shape of the wave as a function of x is a sine function, means that will move into the like a sine direction. Next one, at any fixed position x is equal to x naught. In case of time t is equal to t naught, the omega t will be at a constant. Then remaining if the position is at constant, at any fixed position x is equal to x naught, then y of x naught t is equal to a sin of constant minus omega t. Here the position remains constant and the angular frequency at time will be stays at same as this. Then the displacement y is sinusoidally varies with the time of t. Sinusoidally varies with the time t. So that's why the function representing whenever the wave is traveling in a negative x direction, then the wave function can be displacement relation y of x comma t is equal to a sin of kx plus omega t plus pi. When the wave is traveling in a negative x direction, can be represented as y of x comma t is equal to a sin of kx plus omega t plus pi. This is the relation when the displacement of a traveling wave is in positive x direction, then y of x comma t is equal to a sin of kx minus omega t plus pi. Then in case of negative direction, the y of x comma t is equal to a sin of kx plus omega t plus pi will be the equation for the progressive wave, the displacement relation for the progressive wave.